Thank you, thank you. So as he mentioned, I'm going to be talking a little bit about performance, but not necessarily the same part that you usually focus on. And we're talking about how to achieve instant navigations inside of Angular. And before I start talking about that, it's important that I clarify what I mean by navigations. You see, most of your users of your applications don't spend their time loading your page. Hopefully, you develop on applications where a user spends their time, they actually interact with the page, and they go way beyond just opening the application. From actual just user data out there from Crux, we can see that most users, or 90% of the time of your users, is spent actually interacting after that page is loaded. And of course, this takes a lot of websites like WordPress and that. If you have an application with more interactions, you actually might have like 30 minutes of a user experience where only 10 seconds or like 5 seconds are actually related to that first load. So that's what I'm talking about today, is how to speed up everything that comes after that, every future navigation, and how to make those feel instant. What I'm trying to show you how to do today is essentially this. This is the before and after of the demo that I'm showing. On the before, you'll see that this is an application that is already quite optimized in multiple different ways, and it actually takes around 2 seconds to transition from the landing page to the next page. 2 seconds really depends on your network connection. Here I'm talking about like a mid-tier mobile, so I traveled from Paris to here driving. That's more or less what the network would be on the highway. That would also be at my hotel today, actually, because it has terrible Wi-Fi. And the second example you will see is 100 milliseconds to 500 milliseconds, give or take. That just kind of depends on your device. So from 2 seconds to 250 milliseconds is more or less what I want to show you how to do. Before I start, thank you already for the wonderful introduction, but my name is Christopher Holder, and I am a performance engineer. My bread and butter, the thing that I do every day, is actually look at large applications and figure out like where is the pain point and how do you make them faster. And so I focus on this not just because I like to make things faster and because I'm very impatient, but because your users want it to be faster. And the faster your application is, the better Google actually recognizes it, and the better the experience for your users and time that they spent on it is. But as I mentioned, the first point is actually about measuring. Like, I'm talking about how to make it faster, but what does faster actually mean, especially for navigations themselves? And you probably have heard of LCP. Who of you has already heard of LCP? Okay, quite a lot of you. So there's a couple important things to think about when we talk about LCP. It's not just that little metric that you see at Lighthouse. It's more of the reason why it is. So it's important to note that this is a user-centric metric, and it's about perceived performance. Not how fast it is, not how fast a piece of content actually takes, but how fast it feels for the user. That's why it measures the largest piece of content. Because if I was to take a guess on your application, that large piece of content probably is the first moment that your user thinks, I can use the application now. It's useful. It's the first piece. And again, this is just to measure like how fast it actually feels on this first thing. On a normal navigation, essentially you're trying to reach under 2.5 seconds. But in an application further, you probably want to reach a lot faster than that. You want to make it feel like changing the page of a book. If you were on a Kindle, for example, and just switch the page, and every switch takes 2.5 seconds, that feels like a terrible user experience. But on a first navigation, under 2.5 seconds is the goal we're trying to reach, and anywhere over 4 seconds is already bad. A lot of the work that you can do to improve that first navigation has to do with lazy loading things and server-side rendering and optimizing these different parts, and those will probably affect the second navigation that you have on the page. However, we also have a cool tool or a cool framework that we can use to think about how do we optimize this, right? We have 4 different sections. We have the time to first byte. How long does it take for your server to actually respond and give you some type of content. Then we have the resource load delay, all right? So how long before between the moment that HTML is entering your browser and the resource, the LCP image or whatever it is, actually starts loading, and from the moment that it actually started loading to the end of the loading, that is the resource load time, as the name very obviously implies. It's important to note that the LCP resource usually is an image, but it doesn't have to be an image. You can have a large piece of text or any other piece. And finally, usually the smallest part is the element render delay, which is just that last part when you already have the content and you want to go ahead and display it on the actual screen. But you might already notice something here. I'm talking about next navigation. And this doesn't really work because I'm talking about the time to first byte, which is where I have to start by making the distinction between a multi-page application and a single-page application. Of course, most of you work with Angular and other frameworks, so you're probably aware of the difference. Essentially, it's visible within the actual navigations, right? In a multi-page application, every time that you actually navigate, click on a link or something new, you get a new HTML document and you restart the actual process, and it's like a full new context that you're actually getting there, or mostly a new context, right? But on a single page application, you click on a link, you get the initial HTML, and every subsequent interaction most likely goes ahead and loads some JavaScript or just changes certain parts of the DOM so that it is visible for you that there is an interaction, a visual change. It can also load some resources, like for example, some JSONs or images during this process. And it comes to this very important distinction between a hard navigation, which is that first navigation, or in a multi-page application, every navigation, and then the soft navigation, which is when you click on a link and then you usually get a loading spinner and actually load some new content. But it has a little bit more than that. Essentially, there is a heuristic, which is still experimental, but hopefully will be available for everyone pretty soon. And that is the soft navigation heuristic. Essentially, it says that when you have a history change, URL changes, and content changes on the page, we can probably consider this to be a navigation. It's not a hard navigation because we didn't get a new document, but it is a soft navigation. There's one very important reason why it matters, and it is because when we track performance, we're all used to thinking about core web vitals, for example, the LCP value. But the LCP value requires that new document. So we no longer get this measurement that comes out of the box. And so this soft navigation heuristic essentially allows us to actually measure that. It allows us to measure from that click, that second LCP event in that second navigation, to track the performance of the future navigations there. So the basic change is quite visible. We no longer have the time to first byte. That is now gone. And some additional changes in the loading pattern that actually happen. We have a lot more JavaScript that loads, and essentially instead of loading a actual HTML document, we load a route, we load a deferred component, and probably some data that you're going to use, maybe some additional data, the image, and we render whatever we're going to render on the screen. So this is essentially what your secondary, but initial, because it's still the initial state that I'm trying to show you for the secondary navigation, where you load your routes, you load the data, you load the image, and you render it on the screen. This is the 2 to 2.5 second interaction. And as trying to improve it, when we take a look at these 3 different sections, we have to try to figure out how to move this work to actually improve the speed of the navigations. And I love to reinvent the wheel. But somebody already did it for me. So I don't actually have to rethink about all of this. How many of you have actually heard of the speculative rules API? That is amazing. Congratulations, man. Yeah. So it is a new experimental API that is truly amazing and revolutionizing the way that you actually navigate on the web for multi-page applications. Essentially, you can add a script tag and pass it additional metadata about this, and it will go ahead and preload and pre-render the actual page behind the scene. It'll make navigations feel absolutely instant. But a couple things to note. Only works for future navigations, so it's not for your first navigation on the page. It targets the actual HTML documents, so not for multi-page applications, and it doesn't really work for Angular in that case. Just to show you why that's like super important, let's go ahead and touch a little demo really quickly. It's a super straightforward demo where you can actually just feel the actual difference in performance of these two. So let me start by loading the default version here. And in the default version of the application, this is not the secondary demo that has things. I try to make the design a little bit prettier, not much, but you know, at least a little more than this. And here I have a super simple script that essentially tracks all of the soft navigations and will display the LCP of those on the screen. So I'm going to go ahead and start that script and put this just on a mid-tier device. Like I said, need traveling on the highway, maybe with a little bit of low battery. So my phone is a bit stressed. And I'm going to go ahead and click on just a button. Sorry, the script is for the next part. That is the LCP value that you're actually getting here. The initial nav took approximately 10 seconds. So I clicked on an actual link, and in 10 seconds, the LCP value was actually displayed on the screen. That is kind of an average experience, to be honest, on a mobile device when looking at a multi-page application or the initial navigation on your SPA. So here is the same thing, but this time with speculative links activated. We're using mid-tier mobile, and I'm just going to go ahead and remove the cache and reload. Give it a moment for this to finish loading. Now, I'm going to go ahead and do the exact same navigation, and you're going to see that it took 680 milliseconds to actually load. That performance difference is just absolutely massive. And of course, like, you know, this is a multi-page applications, so you think your application has to be like so much faster than that, right? Because you've already loaded the initial documents. You're no longer hitting that server for the first time. So again, I have an application which has been optimized for performance, and we can actually take a look at what that looks like. We can actually go ahead, load this application, and like I said, we need to use the script, as in this case, since it's an Angular application, we are going to see the performance of the second navigation, and that will not be tracked by the same hard navigation API. So I can now go ahead and do mid-tier throttling and just click on any of the navigations. And we are loading, still loading. And 5 seconds, the Wi-Fi is starting to get a little bit slower. So I said 2.5 seconds. Apparently this is a little bit more intense than that right now. Yeah. Again, this is an application that is already optimized in many ways to improve the performance and the loading, but you loaded a new route, you loaded a new bundle, and you deferred some things in the meantime. So of course, this takes quite a bit of time. There is another reason why speculative rules API doesn't feel like enough, and that is that it's currently not implemented on all browsers, so we also don't have access to it on Firefox or on Safari. So you're essentially avoiding all of your Apple users, and there's a lot of Apple users, which could be very important for your organization. How can we actually achieve this inside of Angular? And fortunately for me, again, did not have to reinvent the wheel. There is already a base implementation called Quick Links, which is essentially kind of framework agnostic, and one specifically for Angular, which is called NGX Quick Link, created by Minko Getchev, which essentially uses an intersection observer to see the different links that are on your website and attempt to preload the routes for it. This will target this first section, which is probably one of the most important ones, right? Because when you still haven't loaded the JavaScript, you often end up with just a page that is not moving, not really reacting or anything, until the actual JavaScript loads and you can actually navigate away. So we are removing those two first sections that are now marked in red, and essentially making the first, like from the click to the actual movement, feel a lot faster. But of course, this is only the beginning of the journey. This is only the first part where we actually get to make that improvement, and we are left with this. Now we have the critical data that we were originally like loading at the end, but now that we have the bundles, we should attempt to figure out how to load them even earlier than that. And that is why we've developed this concept called the pre-resolvers. In Angular, you have the ability to actually create resolvers, like data inside your router that connects directly to whichever route you're getting and pulling it in to your components or whatever state management solution you have. So if you are using something like that, why not connect the same idea of the like preloading of the routes with that? Top of that, you might have the situation in which your route itself contains some data about what needs to be loaded. For example, here we have a movie, and the movie has an which is actually a parameter of the router. So you need to be able to connect the two. Essentially, what we did is we used the same mechanism so that when we see a link, we can actually execute something inside of your router and just say, hey, if this link has entered the viewport, go ahead and execute the pre-resolve method of the route. This will essentially take the route, as an example, the activated route snapshot. But of course, since this is before the navigation has actually occurred, it's not quite there. Like if you're looking to find some state of the route, it won't be there. You are just going to be able to get the parameters or any information that you need in that regards to actually execute something. And you have to execute it as a side effect. For example, an easy way to use this is if you're fetching some JSON data from an API, rely on HTTP cache, fetch the data. When you actually get to rendering your component, fetch it again, but it's already there because it is inside of your HTTP cache. Yes, you lose a couple of milliseconds. Not really a huge issue. Very easy to actually use, run any side effect you want, and we go that way. And that is when we've now removed the two next sections. It's this whole like white space or loading screen that you have in between before you actually get the data. It's important to recognize that also you're like deleting and re-adding content. So if you don't have that, you might also speed up the rendering of the application. But I did leave a blank space there because there is still something else. And I'll talk about that in a moment. But this is also probably a good moment to throw a disclaimer. Just a piece of information because of what we've learned over time. And that is be careful. Be careful with your servers. You really need to know how much your servers will tolerate to do this. Because if you are speculating on the navigations, you're going to over-speculate. Your user is not going to click on all the links. And let's say you have 30 or 100 links on that page, and now you're going to hit the server 100 times more. Make sure that your server is able to actually handle that, or expect your servers to go down every once in a while. Yeah. The second part, just as a disclaimer, is how you actually want to handle guards. If you have guards that cause like navigation to go away, and you would like to actually run all your guards, you might enter in a situation where as the link enters the viewport, boom, you navigate to a different page. So you actually have to be more careful about that, or simply not execute the guards during that transition, which is a very valid option. Yeah. So with that disclaimer being said, there is then the last part, which is the actual LCP resource, usually an image or a large piece of content. And there is a very easy way to actually get that. And it is to natively just use a link preload tag, and you can pass it different parameters to actually choose whether or not it gets loaded on different size of devices and everything, essentially just preloading the image before time. Essentially, this will improve the navigation from this version over here to this, where you now get instantly, you click on something, you have the loading state, which is basically gone, or the rendering state, and everything is ready for you to use in that instance. But of course, we have that one piece that I told you will stay for later, and that is to actually optimize the rendering of your application, all of the actual creation of the DOM and all of that. And for that, I am also not going to explain. There is a wonderful talk from a colleague of mine called Cut My Task into Pieces. Has a great song attached to it. If you're interested in looking up how to improve the rendering performance, you can go ahead and check out the talk there. It should be on YouTube. And if you are interested in actually implementing that in your application and improve the rendering performance, you can go ahead and check out RX Angler, which is a fantastic way to optimize all of the rendering going on inside of your application. So let me actually show you the demo and show you the actual improvement and how you can actually identify the different parts of this improvement. I also have the application running locally, all right? And we can go ahead and take a look. I'm sure this is very tiny. Let's see if I can get the right size. Great. So here we have the application configuration, all right? And I've gone ahead and added one small part. It is in the provide router function, where I'm essentially providing a preloading strategy, which I call with speculative link preloading, right? The reason why I'm calling it preloading strategy is because under the hood, I'm essentially using with preloading and passing it a specific strategy that would define what actual pieces get loaded at what moment in time. So inside then of a component where I have any type of link, I just go ahead and add a directive where I pass it the actual link, where it should speculate and say this is the potential one that is going to reuse. If we wanted to, we could also attempt to attach this directly to the router, but it would make things easier if you go this route. And finally, inside the router, as I told you, it's extremely straightforward. You just go ahead and throw it a side effect and say, hey, like, I want to run a side effect. My side effect here is going to be getting the movies, and after I get the movies, I want to go ahead and preload the image. Of course, there are more things that you could load, and you could be a lot more, you could also use a lot more things from the actual router that we're using, the identifier, which is the parameter that it's actually using from the router. So let's take a look at that in action. Great. So now we have the same application, and I am going to go ahead and just empty cache and reload. And first thing I'm going to do is just open up the side menu, all right? Normally, you wouldn't really get much that happens here, but as I open up the side menu, a lot more links become available. So a lot more potential navigations can actually be done since I've actually clicked on this. I now have already loaded the information for the popular page, and I go ahead, let's just scroll here, yeah. So now we have also the information for the top rated page and for the upcoming ones, so that if I click on this, we'll go ahead and make that navigation much faster because the data is already available. If I go ahead and just scroll down, you'll see that as I scroll down, I actually already load the data for the different movies that I could now click on and load their larger images attached to that. So we actually not only load the small image for a movie, but we actually also load the larger version of the same image. Essentially meaning that we get 2 images for each one, the actual image attached to it, and the image attached to the next navigation, which is simply a slightly different size. Finally, I'm going to go ahead and do the same thing I did on the other page, mid-tier throttling. Going to go ahead and turn on that script, and now just navigate to the next page and see the difference in performance. This now took 960 milliseconds. It might have to do with the fact that I am streaming with 7 or 8 different slides and an application running in the background. So my laptop might be a bit stressed at the moment, but it still improved the navigation from 5 seconds all the way down to 900 milliseconds, which is a very significant improvement. Finally, you might be thinking, hey, like, I don't know, maybe this only works for these tiny demo applications. And here I can just show you that we have an example. For example, on bwin.com, if you were to open it, you'll see that multiple places throughout the application, we're actually using it, and it's a very large-scale application. So you can actually check how we've actually used it to significantly improve, and I think it's like 60% of the navigation time that we've actually reduced on most of the important navigations. If you want to go ahead and check out the repo, where we have the implementation in case you would like to try it out, it is over here in the QR code. This is the use for it. It is very straightforward, and we are very open for comments and understanding how we can actually improve the navigation itself, like the library itself. If you have any questions, and not just about like navigation performance, but anything regarding performance, I am always open to answering questions, especially on X or Twitter, that I am under Chris P. Holder. Thank you very much.